Hello guys, in this video we are going to discuss the solution of the problem intersection point in a Y-shaped linked list. So let us look at the problem statement. The problem statement says given two singly linked lists, return the point where two linked lists intersect. Note, if the linked lists do not merge at any point, return -1. So for instance, if you look at this linked list, this linked list intersect at this point, and at this point the data is 4, because of which we are returning 4. Similarly, in the second linked list, the two linked lists intersect at point 8, because of which we are returning 8. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us take an example. So let us say this is the linked list which is given to us. Let's say this linked list is pointed by head 1 and this linked list is pointed by head 2. Now the general idea behind solving this problem is, first let us count the number of nodes in head 1. So the number of nodes in head 1 is 5. Similarly, let us count the number of nodes in linked list 2. So in linked list 2, the number of head is 6. Once we realize this, what we are going to do is we are going to increase the linked list which has larger number of nodes. We have to move the head pointer such that the number of nodes of head 1 and head 2 becomes equal. So what do I mean by this is, so the difference between the number of nodes is 6 minus 5, which is equals to 1. So the larger node, which is this node, the head of this node will be moved by 1 position. So now head 2 is at this position. And in this way, we are going to update the head of the linked list with larger number of nodes. And after shifting the head of the linked list, now we know that both the linked list contains same number of nodes. Now, in order to find the common point, all we have to do is we have to start iterating on the linked list. So for that, all we have to do is while head 1 and head 2 and head 1 is not equals to head 2. Since we need to find the common point, that is why head 1 is not equals to head 2. And then all we have to do is we just have to increase our next pointer. So head 1 and head 2 equals to head 2 dot next. Over here this is head 1. And in this way we will be able to find the common point. So for instance, in this example, we will be at this position. And at this position, since head 1 and head 2 are not equal, because of which we are going to increase head 1 and head 2 by 1. So now head 1 is here and head 2 is at this position. So this is my head 2 and this is head 1. Again, they are not equal. We are going to increase it by 1. So now over here, head 1 and head 2 are here. And at this position, this condition will not get satisfied, because of which we'll break from this loop and we are going to return head 1 dot data. And for the case where we are not able to find the common node or there is no common node, in such case head 1 and head 2 will become empty, and then in that case we are going to return -1. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to find the intersection point and head 1 and head 2 is given to us. So for this, first we need to compute the length of head 1 and head 2. So let us compute length of head 1. Similarly, length of head 2. And after computing the length of head 1 and head 2, let us compare. If n1 is greater than n2, then in such case, return intersect head 1, head 2, n1 and n2. Otherwise, return intersect head 2, head 1, n2 and n1. And folks, the if condition is only to ensure that the first node has the maximum number of nodes or the larger number of nodes. So in this case, head 1 has the largest number of nodes, because of which I am sending head 1. In this case, head 2 has the largest number of nodes, because of which I am sending head 2. And in this way, we will be able to find the intersection point and we will be able to return it. Now let us look at these two functions, which is ll length and intersect. So let us say we want to compute the length of a linked list and the head of the linked list is given to us. So for that, let's take count equals to 0 and then let's iterate on the linked list. And in that, all we have to do is increase count by 1 and move head to the next node. And towards the end, we just have to return, and towards the end, we just have to return count. And in this way, we will be able to compute the length of the linked list. Now let us look at the intersect function. So let us say intersect point is what we want to find out. Head 1 and head 2 is given to us. N1 and N2 is also given to us. So the first thing which we are going to do over here is we are going to move head 1 such that length of linked list head 1 and head 2 becomes equal. So for that, all we have to do is while n1 is not equals to n2, and in this case let us just decrement n1 by 1 and move head 1 to the next node, and by the end of this loop the length of linked list head 1 and head 2 will become equal. After that, we just have to iterate on the linked list while head 1 and head 2, and head 1 is not equals to head 2, and all we have to do is we just have to update our head 1 and head 2 pointer, and in this way we will be able to find the intersection point. And after this, all we have to do is we have to check if not head 1 or not head 2, which simply means there was no intersection point. If there was an intersection point, then in such case head 1 and head 2 will not be empty. Since they are empty, because of which we are going to return -1, indicating that there is no intersection point. Otherwise, we just have to return the intersection point, which is head1 dot data. So that's the discussion of pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. So over here, this is the main function which we want to update. Over here, first we are computing the length of the linked list, and then we want to find the intersect point. Now let us look at the length of the linked list function. In this function, count equals to 0 while head, and then we are counting the number of heads. Towards the end we are returning count. And in the intersect function, head 1, head 2, n1 and n2 are given to us. First thing which we are doing is we are moving the head 1 pointer. After that we are finding the intersection point. If there isn't exist any intersection point, then we are returning -1. Otherwise we are returning intersection point. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. First we find the length of the linked list, then we are finding out the intersection point. In length of the linked list function, count equals to 0 while head count plus plus head equals to head of next, and towards the end we are returning count. In the intersect function, we have head 1, head 2, n1 and n2 given to us. First we move head 1 such that length of linked list head 1 and head 2 becomes equal. After that we are finding the intersection point. If there isn't exist any intersection point, then return -1, otherwise return the intersection point. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.